Yes, class. Am I audible? Donna and Samaira. So, Donna, where were you? You were not attending classes? Last 2 to 3 class, I think you were not there. Exams were going on. Yes, Donna, am I audible to you? Samaira, are you able to hear?
Yes, ma'am.
Okay, then let me check. Okay, class. And anyways, we had started with microscopes. Let me just give you a brief what we have discussed. So see, microscopes we have seen. Simple microscopes were there and compound microscopes are there. So in case of simple microscope, 2 cases we have. Always we'll take 2 cases. One was when final image was at least distance of distinct vision. Second case was when final image is formed at infinity. So for least distance of distinct vision, magnification's formula was 1 by d by f. This was the formula. And for simple microscope, it was simply d by f. For compound microscope also, we had seen 2 cases. One was when image was at final least distance of distinct vision and when image was formed at infinity. Now see, magnification will be what? Here it will be V by U, V naught by U naught, or you can say 1 plus D by FE. For final image, you can say V naught minus V naught by U naught D by FE. These were the formula we had seen in the last class for compound microscope also and for this one. So V naught by U naught is equal to FE divided by FE. So this is a summary of what we have studied. Like this only, you have to remember it. Simple microscopes on one side, compound microscopes on another side, like this. Then make both the cases. Least distance of distinct vision case as well as infinity case. Least distance of distinct vision case, infinity case for compound microscopes. Then write M is equal to 1 plus D by F. Here M is equal to D by F. Here positive sign was only there. M is equal to D by F. Then for compound microscope, multiply this term by V naught by U naught and here V naught by U naught, and focus becomes focus of eyepiece. So these 2 things were there. Numericals also we had done. One numerical from compound microscope was left. So let's do this question. It says that you are given 2 converging lengths of focal length 1.25 centimeters and 5 centimeters to design a compound microscope. See, since the aperture is small, this will be the objective length. Since the aperture is large, focal length is high, this becomes the focal length of eyepiece. This is how you will identify both the foci in your exams. So to design a compound microscope, both the foci are present. Find angular magnification is final images at least distance of distinct vision. By the way, what was least distance of distinct vision? What was the value of least distance of 25 centimeters, right? 25 centimeters. Good, Priya. So first part says image is at least distance of distinct vision. So magnification formula. This is V naught by U naught 1 plus D by FE. Right. This is M is equal to V naught by U naught 1 plus D by FE. Now see here what you have. You are given converging lenses of focal length to one of 1.25 centimeters and another one is at 5 centimeters. And this is there to design a compound microscope. Now, when it comes to you that compound microscope is only present, so you will forget all the cases that you have studied for a simple microscope. Right now, you will only focus on both the formula we have done. Remember, both the formula we have done it for the compound microscope. Now coming, see what you're asking. No, that is how you will choose is You will choose it from the question. In the question, it will be directly mentioned to you. Clear? In the question, it will be mentioned to you that whether you have to choose simple microscope or you have to choose compound microscope. It will be mentioned to you in the question. Otherwise, how will you solve it? Right. Now, coming back to the question. Yes. So this is given to, you are given two converging lenses of focal and, yeah. So yes, understood how to choose. See, here it is given compound microscope. So in every question it will be given. Okay, so magnification's formula is this. We have to find out what? We have to find out this one, magnification. Now see here, okay, in the question, no, U naught was also given. U naught was given as 30 centimeters. So minus 30 centimeters we'll take it. This was a part of question. This was part of a question. Minus 30 centimeters. It was given just 30 centimeters. We'll add this from our side minus sign because to use sign convention. Now the only thing that is missing is V naught. So if you know F naught, which is 1.25 centimeters, if you know U naught, whose magnitude is 30 centimeters, minus 30 centimeters is the complete. So V naught can easily be calculated using lens formula. So see how to solve such questions. In these questions, now you have to first find out V naught's value. You'll use 1 by F naught is 1 by V naught minus 1 by U naught. So 1 by V naught will be equal to 1 by F naught plus 1 by U naught, which will be 1 by 2.5 minus 1 by 30. This will give you value of 1 by V naught. Then you will take V naught and put it in the formula. So U naught is given minus 30. D, you already know this is minus 25 centimeters. And Fe is also given as 5 centimeters. This you can solve and check. And for the second part, see, second part is when image is formed at infinity. So just this part, V naught by U naught, one will get removed. You will just have D by F. You will just have D by F. So it will be one less than what we have calculated. Okay, note it down. Okay, class. Now the last topic from the optical instruments is telescope. So astronomical telescope, we have to see. Astronomical telescope is basically a refracting type of telescope that is used to see heavenly bodies like stars, planets, satellites, and all. So construction is same. Objective lens will be there. Eyepiece will be there. Let me show you. Both the cases you will have. Let's say case 1. So both the cases you will have when final images at least distance of distinct vision. Least distance of distinct vision. Now let me tell you the construction of this. In case of compound microscope, we had what? We had the objective lens smaller, whereas we had the, which one? Eyepiece greater. Now see, here in case of astronomical telescope, objective lens will be a convex lens, same way, but a larger focal length will be there with a larger aperture. So this will be greater in comparison to this. This is just the difference that will arise. This will become your objective lens, and this will become your eyepiece. Fine, class. Now see, keep an object. See, for astronomical telescope, we cannot keep an object like this very near to the lens, because astronomical telescope is used to see objects that are already at infinity, like planets. Using telescope, we observe, we see planets. So planet is the distance that the planet has is finite. But if you consider that distance, which is actually separated from the lens, wherever the lens is present, to the final separation, that will be almost infinity. Let's assume that this is infinity. Let's assume this is coming from infinity, so that you have an idea. Yes, this is from infinity. Now see how the lines will go. Let me just drop it. Okay, let's assume these rays are coming. So this will collide with the optical center. This will get refracted. This ray will pass through the optical center, will get refracted. This will not be reflected. Sorry, the second ray, the ray that passes through the optical center, the way the rays that pass through center of curvature, they just retrace their path itself. Same thing will happen here. So same thing, the way we have studied for compound microscope. Now here one intermediate image will be formed, the way an intermediate image was formed. Just the difference is regarding this class only. Rest is same. Let's say this is A dash, B dash. Right. Now, one thing, remember we chose an angle alpha that was subtended. I have made it infinity. We chose an angle alpha that was the angle subtended by the image on eye when at normal distance, least distance of distinct vision. So let's say this is alpha. These are rays coming from distant objects. And finally, what will happen? These rays, they'll be refracted by the eyepiece, and these rays will meet at a point. Let's say here they have met, So this becomes the final image, A double dash, B double dash. Do you see how much enlarged it is than the real? In the sense, if obviously real's image size is very huge. We cannot keep it in front of the lens. The satellite, you cannot keep in front of the lens in the place of a slide. So image is formed in comparison to simple microscopes and compound microscopes. The image is larger. All right, and this will go into the human eye. These rays will enter the human eye. Here we have formed our image, and the angle that is subtended by it. If I drop it, like this, the angle that is subtended, this angle is beta. Same thing. Now, coming to the angular magnification part, magnifying power, we have to find out. Now, see, magnification's formula will be same thing you will have in the triangles. Magnification's definition is same. Magnification is ratio of angles subtended by image, final image at least distance of distinct vision. So that becomes, okay, one thing I didn't tell you, the markings. Final image is formed at least distance of distinct vision, capital D. This will become capital D. And this is the object distance for the eyepiece. Why? Because this intermediate image is acting as an object for this eyepiece, right? And what else? Focus is there for the objective lens. This will be the focus because rays are coming from infinity, so they'll converge at focus, and rest of the part will be for the focus of eyepiece. Now coming to the definition of magnification. So angle subtended by image on eye when at least distance of distinct vision. So this is the image which is at least distance of distinct vision. So this is beta divided by object when it is at least distance of distinct vision. So same thing, m is equal to beta by alpha, and the way we use small angle approximation, where you can almost write it as tan beta by tan alpha. Now magnification, exactly same thing, class. This is a very short topic. After this, we'll start with Prism directly. See, this will again, same thing, A dash, B dash by B dash E. Let us name this optical center of the eyepiece as E. Otherwise, the triangle will be incomplete because O, we have already chosen the optical center for objective lens, and divided by tan alpha. So this will be reciprocal. So O B dash by A dash B dash. A dash B dash gets cancelled. Again, O B dash by B dash. Same thing, same derivation, class. O B dash is what? See, this is O, this is B dash. This is the focus of the objective lens. See, O, B dash, focus of objective lens. Right. And B dash E, see, B dash E is UE, that is object lens for eyepiece. This is the intermediate image that is acting as virtual object for eyepiece. So this becomes UE, that is object distance of eyepiece. So OB dash is what? OB dash is focal length of objective lens, while B dash is image distance for it, right? So magnification becomes minus F naught by UE till now. But see, now we'll use lens formula. Lens formula to find out the value. So see, U object distance is minus UE. Image distance is minus D. We know this, no? We are actually finding out the focal length of eyepiece. Now coming and applying 1 by V is 1 by V minus 1 by U. One by F is equal to 1 by V minus 1 by U you have. So from here, 1 by FE will be equal to 1 by minus D plus 1 by UE. If we have to write 1 by UE, no, minus 1 by D minus UE, yes. So 1 by UE, if we have to write just 1 by UE, that will be 1 by FE plus 1 by D. Everything will become positive. Now from here, M is equal to, not magnification. Firstly, let us take capital D common. Or let us not take capital D common. We'll find it at the end. Now see the formula that we had obtained. Minus F naught by UE. Minus F naught by UE. Can I write it as minus F naught multiplied by 1 by UE? Same thing. Now 1 by UE is exactly this. So magnification becomes minus F naught 1 by UE, that is 1 by Fe plus 1 by D. So better way to write this magnification is by taking D common, Fe common, so that becomes F naught by Fe. Just multiply Fe common, 1 plus Fe by D. Do not again use sign convention, no sign convention. For optical instruments, we do not use it. All right, copy down this case. Anything that you have not understood, ask me. I'll repeat it if any portion you have not understood. Now, second case, no, that final image is at infinity. That is easier than this, very easy, a very short derivation is there. Complete it, then we have to start with Prism. See, case 2 is when final image is formed at infinity. So till here, everything will be the same. No difference will arise. Now see class, when the final image will be formed, the rays will be parallel. So like this image will be formed at infinity. Understood? So if this object distance, now if the rays are parallel and they are forming at infinity, it means this distance. This is for sure the focal length. That was initially object distance. Object distance is now equal to the focal length of the eyepiece. This will be the difference that will be there. Rest F naught and everything that will be same. Same thing here also, difference will be there in the magnification as well. So magnification will be same till this part, because now lens formula is not needed. And difference will be that here the value of B dash E instead of UE, we'll prefer to write as FE. So this will become FE. So magnification will be F naught by FE. This is all about telescope. Quickly copy it down. Then we have to start with Prism. Any doubts you have till now from optical instruments, any part, let me know, class. And then we'll practice some more numericals from optical instruments. Because from optical instruments, direct questions come, but sometimes the calculations become confusing. F naught and Fe, that because see, for this lens, no objective lens, focus is present where? Focus is present on the right side. According to the sign convention, this will be taken positive. But this focal length for eyepiece, this is the first primary focal length. So first primary will always be negative because this is lying in front of the lens. So if you, according to sign convention, for objective, this is falling behind. And for IP, this is falling in front of it. That's why we have taken the opposite sign conventions. Clear?
Yes.
Okay. So all of you have completed. Can we start with Prism now? If you have any doubts, let me know. Okay, then let's start with Prism. So this is the last topic that is left. Some portion of it will be left that we'll complete on Monday. So complete lesson will be over. Whatever topics we have studied before optical instruments, apparent depth, total internal reflection, spherical refracting surface, refraction basically. After reflection and before optical instruments, I'll take a test of that. On Tuesday, I'll take the test. All right. Tuesday, that is 29th. No, so 29th ko I'll take the test. Now see, prism is what? Prism is not just a simple mere triangle that is observed. Prism is actually made up of two triangular surfaces like this. This will be one triangular surface, another one will be, this will be another triangular surface. Now, how these triangular surfaces are connected? They are connected with the help of rectangles, rectangular slabs like this. This is one rectangle face. Then in the bottom, one rectangle face, and in the side rectangle face. So like this, three rectangular faces with two triangles. This is actually how prism looks like. This is not just a 3D form of triangle or in the form of cone. It is wedge shaped. Wedge, you understand? This shape is known as wedge shaped. So prism is what? Wedge-shaped portion of transparent refractive medium bounded by two plane surfaces inclined to each other at a certain angle. So this angle that is formed by these refracting planes, this angle is known as angle of prism. This is how the construction of prism is made. Now, this part that you observe, these parts, these basically rectangular parts, these are the refracting parts. From here, the light rays will enter, from other one it will get deviated and refracted. Now, when the rays will come, there will be a certain point where deviation will occur. As in, let me draw a prism and let me show you. This derivation is important, class. This derivation is very important because your external examiner also, if you get this experiment in your practicals, can ask you questions from here as well and can ask you to prove the derivation also. So be prepared with this derivation at least. Fine. Now, C class. So this is a prism. Now, ray of light will be incident. This is the incident ray. At this surface, a normal will be dropped and then refraction occurs. And then again, refraction will occur at the second surface also. So see, this is angle of incidence. This is angle of refraction, let's say R1. And at this surface also, we'll drop a normal, let's say N1. This is N2. And this is, let's say this is R2, angle of incidence from inside. And finally, it will come out and this becomes angle of emergence. This is same. This was exactly what we have studied for compound plate. Remember, like this only, but just the difference was there was no inclination like this. This is angle of prism. So let's name this A, B, C, D. Let's name this quadrilateral. Let's say this angle is some angle X. Now, if you look at this triangle BDC, in triangle BDC, R1 plus R2 plus X, this will be equal to 180 degree because of angle sum property of a triangle. So R1 plus R2 will be equal to 180 minus X. All right. Now look at the complete entire quadrilateral. ABCD. In quadrilateral ABCD. So angle A plus this entire angle plus this entire angle. Right. If you look at this, okay, or let's not take such a huge quadrilateral. Let's make it narrow. Now see exactly what angle of deviation is. If this light was, if there was no prism, this incident ray of light would have covered this path. Yes. And now what is the path of it? C. So it means this much deviation has occurred. This much of deviation has occurred. This is known as angle of deviation. This is known as angle of deviation. Fine. This entire angle is known as angle of deviation. Now, see, now this is easier for you to understand. Now look at the quadrilateral, which I was saying, ABCD. See, in quadrilateral, opposite angles have the sum 180 degree. So angle A plus X will be 180 degree. So angle A will be equal to 180 degree minus X. Can you notice this equation first and this equation second? R1 plus R2 is also 180 minus X. A is also 180 minus X. So R1 plus R2 will be equal to angle A. This is a very important result which you have to remember. This will be used throughout. Let's say this angle is angle 1. This angle is angle 2 because we need it for the derivation. This has no physical meaning, just for the derivation. Now see, if you notice, no, just look here once. Look here. Look here. In this triangle, if you see this entire angle, can anyone tell me what is this entire angle? This entire angle. Yes, class. See, this is angle of incidence I. So this will also be angle of incidence I. It means 1 plus R1 is equal to angle of incidence. Same thing here. If this is angle of emergence E, so this angle will also be as same as that of angle of emergence E. This part is clear to all of you?
Yes, ma'am.
Okay. Now see, carefully look here. It means angle 1 plus angle R1 is equal to angle of incidence I. So I can write it as, or R1 I can, let me write R1 first. R1 can be written as I minus angle 1. Now coming, same thing that is applied on the opposite side for E. So angle 2 plus angle of emergence is equal to, angle 2 plus R2. This is equal to angle of emergence. So R2 will be equal to emergence minus angle 2. Now see here, if you look at this triangle ABD, this triangle that has been formed, ABD. Can you see this exterior angle is this delta, the angle of deviation? This is delta. Delta is the angle of deviation. So 1 plus 2 will be equal to delta using exterior angle property. Whenever you have an exterior angle, no, it is like the delta is the exterior angle. So exterior angle will be sum of opposite interior angles. Now put the values of it. It will be the sum of 1 and 2. This will be the sum of 1 and 2, not R1 and R2. It will be the sum of 1 and 2. I have written here R1 and R2. This will be the sum of angle 1 and 2. So angle 1 plus angle 2. Now angle 1 plus angle 2's value, we have it from here. If you look at these equations, if you look at both of these equations, instead of R1 and R2, no, we have to write and find the value of 1. 1 and 2 are needed. We have to eliminate 1, no? So angle 1 is equal to I minus R1. Angle 2 is equal to E minus R2. So delta will be I minus R1 plus E minus R2. So I plus E together minus R1 minus R2. So delta becomes I plus E minus R1 plus R2. What is R1 plus R2? A, angle of prism. So delta is equal to I plus E minus A. This is the equation. Angle of deviation. This is the equation for it. So where alpha is delta is angle of deviation, I is angle of incidence, E is angle of emergence, and A is angle of prism. This equation's derivation, which we have covered right now, this is important as I have already made you mark also. This derivation comes. Now there is one condition when this becomes very small. There's a one condition where this when the incident radiation will be there will be different values of delta, the angle of deviation. But out of all those value, one will be the least value. So which that least value of deviation, how can we calculate it mathematically? Experimentally, though we can calculate, but mathematically, how can we calculate? Is by these two conditions. See, for a minimum angle of deviation, no, I and E become equal, angle of incidence become equal to angle of emergence, and R1 becomes equal to R2. So now see, if I becomes equal to E and R1 becomes equal to R2, so see, R1 plus R2 was equal to A. So both are same. I can write it as 2R1 as A. So R1 is equal to A by 2, right? R1 is equal to A by 2. Now this equation, delta is equal to I plus E minus A. So I can be written, I and E both are same. So I can write this as delta is equal to 2I minus A. Now look here. Now from here 2I will be equal to delta plus A. I will be equal to delta plus A by 2. Value of R, value of angle of incidence. Now apply Snell's law. I have told you Snell's law's application will be till the end of this lesson. So Snell's law, if you apply, Snell's law is what? Sine I by sine R is equal to refractive index. So value of refractive index will be sine of I is delta plus A by 2 divided by sine R. So sine A by 2. This is the angle of minimum deviations condition. These two are the conditions. And this is the formula for the refractive index. Rest of the things have already been calculated. Tell me, class, this whole topic, angle of minimum deviation, everything that we have studied for Prism, is it clear?
Yes, ma'am.
Okay, clear to only Samaira? What about others? Eamon, Donna, Priya?
Yes, ma'am.
Eamon, you there in the class, Eamon? If you're there present, Eamon, respond. Eamon and Donna. Okay, class, so noted from you. See, let's practice 1, 2 numericals. We have 10 minutes time. It says calculate refractive index of material of an equilateral prism for which angle of minimum deviation is 60 degree. Equilateral prism means angle of prism is 60 degree. Delta is given as 60. This is delta minimum, angle of minimum deviation. And you have to find out the refractive index. So calculate refractive index of a material of an equilateral prism for which angle of minimum deviation is given. So now, class, N formula is sine I, not sine del plus A by 2. Just a second. Okay, yes. So this is sine del minimum plus A by 2 by sine A by 2. So this will become sine 60 plus 60 by 2 divided by sine 60 by 2. So that gives you sine 120 by 2, that is sine 60, and sine 60 by 2, that is sine 30. So sine 60 will be root 3 by 2, sine 30 will be half. So refractive index will be root 3. Like this, you have to apply the formula. I hope it's clear. Note this down. We'll do one numerical if time permits. A ray of light passes through an equilateral prism such that angle of incidence is equal to angle of emergence. Now, angle of emergence is given as 3/4a. And angle of prism for equilateral triangle is 60. So E will become what? 3/4 into 60. Right. So this becomes 180 divided by 4. E is equal to 3/4. That is given in the question. That is a part of question. E is equal to 3/4a. That is a part of question. This, here. Look here. Understood? Okay. Yes, so where were we? Yes, E is 3/4a, so 180/4, so 45 degrees. So angle of emergence is 45. And angle of incidence is equal to emergence given in the question. So angle of incidence will also be 45 degrees. Anything else? Calculate angle of deviation. So angle of deviation can be directly calculated. I plus E minus A. So deviation angle is 45 plus 45 minus 60. So delta is 90 minus 60. Delta is equal to 30. Now, second, this is the answer for the first part, angle of deviation. Second part says refractive index of prism. So same formula this which we have seen. Refractive index will be sine del plus a by 2 by sine a by 2. So here if you put, this will be sine 30 plus 60 by 2 by sine 60 by 2. So n will be sine, see 60 plus 30 will be 90, 90 by 2 will be 45 and 60 by 2 will be 30 degrees. So sine 45 is 1 by root 2, sine 30 is 1 by 2. Even if you rationalize it up and down, this will become root 2. So n is equal to root 2. This is the value of n. So, okay, I'll stop here. Note down this question quickly. Once you've completed, let me know. Some more numericals and we'll end this topic on Tuesday. So the test that I'll take, let me not take it from refraction because refraction is a very lengthy, it's a very big topic. I'll take the test from this topic only, prism only. All right, small test, 2 to 3 questions, class test I'll take on the topic prism only. So prism, at least you can prepare till Tuesday. Refraction is a long, lengthy topic. Those who have completed, you all can leave. Now we'll continue this on Tuesday.